So now we're going to start looking at polar graphs and polar equations and how to do all these conversions. So first are some basic problems. Do some basic conversion into rectangular coordinates, and the general conversion equations we're going to use is, let's see, to rectangular coordinates. Yeah, x is equal to r cosine theta, and y is equal to r sine theta. This is kind of like unit circle, just multiplied by the radius. That's how I think of it. So here, x is equal to be 2 cosine 0, y, 0, not theta, 2 sine 0. So our points are 2, 0. It's still actually also 2, 0. This one is going to be 1 cosine pi and 1 sine pi. You can think of it as just drawing your unit circle if you want. Like, it's radius 1 and we're at pi. So it's gonna be cosine of pi is negative 1. It's gonna be negative 1, 0, right? Here's the same thing. Radius is negative 2 and we're at pi over 2. So I go up to pi over 2 and then I go down negative 2 down to here. Okay, so this is gonna be negative 2, 0. Or sorry, 0, negative 2. And you could also use this equation, negative 2 times cosine and sine. You'll get the same thing. So 0, negative 2. And then here, we draw a picture. We're going to be radius 1. We're going to be at pi over 4. So we're going to be here, radius 1. And what is this? Is root 2 over 2, root 2 over 2. Because, again, it's on a circle. Circle of radius 1, I'm at angle pi over 4. So that's my point. Okay. Now, for each given points, give 2 sets of polar coordinates, then identify it. For each of the given points, give 2 sets of polar coordinates. Okay, so let's kind of let's look at point, say A. It looks like it's radius pi over 4. Sorry, radius 2.5. And the theta would be pi over 4, right? If I look at this as pi over 4, I think from their picture. But you could also think of it from the other side. I could go to this angle down over here to adding pi, so 5 pi over 4, and make the radius negative to flip to this side. Okay. How about B? B is like, we could do negative pi over 3. And it's radius 1. Oh, pi over 6, sorry. But in this case, rather than doing the radius, I could just make the angle go all the way around this way. I could make it pi over 6 away from 2 pi, or just adding 2 pi to it. So that's still radius 1, or 7 pi over 6. See, so there's not, you can do a few different ways. This is pi over 6 away from pi over 2. So I do pi over 2 minus pi over 6. I think that's like, 3, no, this is 3 pi over 2 minus pi over 6, so that's 9, it's 8, it's like 4 pi over 3. I think it's angle 4 pi over 3, and obviously radius is 3. Or we can make it radius 3 and then go this way, which would be negative pi over 2 plus pi over 6, and that's negative 2 pi over 3. Yeah. And then point D is up here. That's pi over 6 away from pi over 2. That's how I think of it. And so that, or you could think of it as there's pi over 3, 2 pi over 3. So it's definitely 2 pi over 3. And the radius looks like 1.5. Or we could go down to this opposite side, go down negative pi over 3, and make it negative 1.5. Like go to this point down here, and then make the radius negative to flip to that side. Okay, so that's a few ways you can. Now we're going to convert rectangular to polar coordinates. And the conversions we use, r is square root of x squared plus y squared. And theta is tangent inverse of y over x, if you don't think about it. But in this case, because we're at 0, 4 up here, 0, positive 4, that is radius 4, and the angle is pi over 2. It's the most direct polar coordinate we can do. And then one where we have negative 1 and root 3. Well, root 3 squared plus 1 squared, this is a radius 2, because it's 3 plus 1 is 4. Square root of 4 is 2. And then if I look at I'm at 1 and then negative root 3. So I'm going to go over 1 and then down negative root 3. I'm going to go down more than I'm going to go over, right? So this is, what's that, negative pi over 3. See, you got to be really good at your unit circle to do the polar stuff, which might have been a while, but you kind of want to be really good at your unit circle. Okay, negative 1 is down over here. Okay, so that's definitely pi plus pi over 4. That's 5 pi over 4. And the radius is square root of 2, because 1 squared plus the distance from the origin is, you know, x is 1, y is 1, so the distance is root 2. 1 squared plus 1 squared. Negative 4, 1. So here we're going to actually use a calculation probably. Is 16 plus 1. 4 squared plus is 16. So square root of 17 is the radius. And the angle is going to be arctangent of 1 over negative 4. I don't know what that is. So let me just use my calculator real quick and put it into radian mode, and arctangent of negative 0.25. That's about equal to negative 0.24 radians. So it's root 17 and negative 0.24. Okay. I don't know if there's a pi equivalent to that. No, not really. Okay, thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.